Hi guys, in this video we're going to look at cobalt's reactions with alkalis, cobalt's reaction with hydrochloric acid. We'll then look at chromate and dichromate ions, the reduction in these chromium species, and then we'll look at a summary of all the chromium reactions we've met before we summarise everything.
So in our video on the precipitation reactions involving transition metals, we looked at a lot of examples, but one we didn't cover is cobalt complexes. But these reactions are similar to the reactions you've seen so far for the other transition metals. So what we're going to look at doing is adding two different bases to a solution of cobalt ions that are surrounded by water ligands. In both cases, the complex ion that we start with is cobalt and 6 lots of water, so the coordination number is 6 and the overall charge on the ion is 2+. In the case of a strong base like sodium hydroxide, it's the hydroxide ions, the OH-, that are going to act as bases in this reaction, and they're going to take one of the hydrogens off the H2O molecules, but only 2 of them because this will balance the charge. What we're left with is a cobalt complex that has 2 OH ligands, 4 H2O ligands still, so there is no charge overall. This complex, however, is copper hydroxide and is solid. This is the precipitate that we get during this precipitation reaction. Because the OH- ions accepted protons from the water ligands, these OH- ions will have formed 2 more moles of water. We can contrast this with what happens when we add a weak base, like ammonia, but in fact we get a very similar reaction where the ammonia will take a proton from 2 of the water ligands, and so we're going to form the same cobalt hydroxide complex, and so we get the same blue precipitate if we add a few drops of ammonia. Instead of forming water, however, we form ammonium ions, so that's NH4 and then has a positive charge because the nitrogen has 4 bonds instead of 3, and these are aqueous. If we allow this solution to stand with the precipitate in it, the precipitate gradually turns pink due to oxidation. Also, we can redissolve our precipitate if we add excess ammonia. This forms a brown solution. The reason we get the brown solution is because the cobalt hydroxide...
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the snap revise smiley face here. Join me today and together let's make A-level chemistry a walk in the park.